Hello class, I hope you're having a good day. We're going to start with lesson 6.4, proportional and non-proportional relationships, starting on page 285. So you should have your notes ready to go in your notebook. The essential question is, how do you identify proportional relationships? There are two quantities are proportional if they have a constant ratio or a constant rate. Two terms are non-proportional if the ratios or rates are not constant. There are three ways to identify proportional relationships. One is constant ratio in a table, which you will be working with today. A straight line that goes through the origin in a graph, which you will work with tomorrow probably. And then there's the equation y equals kx, where k is the constant ratio. Our goal today is to only worry about how to identify a proportion or non-proportional relationship. Okay, this is on page 285 in your textbook. You can see the two quantities are proportional and if they're non-proportional. Look at example 1 with me. Determining where the cost of coffee is proportional to the number of pounds and explain your reasoning. So what you're going to do, you're going to look at the information in a table and you are going to write a ratio. Let's assume that the first one is X. See if I can get this smaller. And the second one is Y. Okay, this is page 285. There you can see where we've listed the proportional and non-proportional, but look at the example Y. Example 1 where the coffee in pounds versus cost in dollars. You're going to assume that this is X and Y, so you're going to create a ratio 1 over 3, 2 over 6, 3 over 9, 4 over 12, and you're going to put them in simplest terms and simplify the fraction. And you're going to see there's a constant ratio of 1/3, 1/3, 1/3. So yes, this is a proportional relationship. So look at the guided practice. It says determine whether the number of legs are proportional to the number of spiders and explain your reasoning. Well, one spider has 8 legs, 2 spiders has 16 legs, and if you were to simplify all of those fractions or ratios, you would get 1/8. So yes, each ratio is equal to 1/8. So yes, this is a proportional relationship. Okay, moving along, this is example 2, how to identify a proportional relationship. Determine whether the number of miles is proportional to the number of hours and explain your reasoning. So you're going to write the rate of time to distance for each hour in simplest form. So 1 over 50, 2 over 70, 3 over 90, 4 over 100. And when you put those in simplest terms, you do not have a constant ratio. So therefore, this is not proportional. So now look at the guided practice. It says determine whether the number of ice cubes is proportional to the number of drinks and explain your reasoning. Well, if you write the ratios, you're going to get 1 over 6, 2 over 14, 3 over 22, and 4 over 30. Well, when you reduce those, you're going to get 1/6, 1/7, 3 over 22 you can't reduce, and 4 over 30 becomes 2 over 15. No, this is not proportional because the rates are not equal. So basically that's just the first part of the lesson that we're going to do today. It's called, we're just identifying if it is proportional or non-proportional. Your assignment is to complete problems 1 through 9 on page 287. Look at the tables because eventually you will be drawing the tables yourself. You will be graphing the ratios as X's and Y's, and then you're going to be able to graph that line and tell me if it's proportional or not. Good luck, and if you have any questions, let me know.